We're developing a new wastewater treatment process that removes nitrogen waste from water. It's an exciting opportunity to take this waste product that is being produced all over the planet and convert it into a source of renewable energy. Globally, there's a massive imbalance in the nitrogen cycle. So just like we put too much carbon up in the air, the same is the case with the nitrogen cycle, only the reverse. We take a lot of inert nitrogen or nitrogen gas from the air and we make ammonia or reactive nitrogen. And this ammonia that we make is used as fertilizer and it feeds the planet. If we didn't produce the artificial fertilizer that we do in the quantities that we do, 40% of the world's population would not exist. We wouldn't be able to feed them. If we don't treat nitrogen, it goes into wastewaterways and causes dead zones or eutrophication zones. If you count all the hypoxic and eutrophic zones in the world, there's over 400 worldwide that are documented. And the number of dead zones has nearly doubled every decade since 1960. It's one of the biggest threats to the environment that we face today, and there's not as much attention to it as there needs to be. If we change the thinking and we realize that all of the constituents that are in the wastewater are valuable resources in and of themselves, actual products, value-add products, then we can really make the entire process of treating water much more energy efficient, much more sustainable, and then also offset major demands that we have with growing population on fresh water supplies that are already very limited. A lot of these wastewater treatment facilities, they have dual pressures. They're meeting two major pressures. One is rising energy costs, as well as there's a lot more stringent nitrogen regulation to decrease the amount of nitrogen that's discharged into water. And so a lot of these facilities are looking for economic and efficient options. And that's exactly what our process aims to do. We have a new technology that will fit into a wastewater treatment facility. What we do is we take the ammonia that's in the wastewater and we convert it to nitrous oxide gas using bacteria. And just doing that improves the efficiency of nitrogen treatment. That's a lot cheaper to do than the conventional process. When we recover the nitrous oxide gas, we can use it to recover energy, either by using it in a combustion reaction with methane, for example, that's often already produced on site in many wastewater treatment facilities. And what it'll do is it'll essentially turbocharge that reaction. So more energy will come out from that combustion reaction, and the end product is nitrogen gas, because the nitrous oxide essentially burns with the methane. We believe it will scale. Right now it's working in our lab at a demonstration level, and next we're going to pilot it. And with this pilot, we hope to prove the technology at a realistic scale and then be able to move on and see if we can commercialize this at full scale.